So today we're going to finish up the task of 1.7. We're on page 56. Now we're going to look a little bit further, a little more complicated work on this one. But the story is that Augustus is now going to start getting rid of some of his candy. Once he gets 100,000 candies, he's going to just start giving them away. And he's going to give away 60% of the candy in the pile each day. So if he's giving away 60%, that means he's keeping 40% each day, right? So you need to think about those two things, and they'll come to play when we're putting together the formulas. And he's only going to start giving away candy when he has 100,000 to work with. So we don't need to concern ourselves with exactly what day that occurs. We're just going to say we're going to start a new distribution, a new sequence when we have 100,000, and we're going to start to decrease that by giving away 60% of it each day. So what I'm going to do, we need to look and see how many pieces of candy are left on day 4 and 8. So what I'm going to do, I'm going to start a table here. And we'll have day number here, day 0, day 1, day 2, day 3, day 4, 5, 6, 7, 8. That'll give us space to answer both of those questions. And then what we want to look at is how much candy is left. So on day 0, he's not giving away any candy yet. So on day 0, let's just say that's the day that he has collected this 100,000 pieces of candy. Now what we're going to do is he's going to give some of that away. He's going to give away 60% of it. So let's do a little calculation here for a giveaway. I'm going to put a line here too. He's going to give away 60%, so we need to multiply this by 60%. 100,000 times 60%, or you could say times 0.6. That's the way to convert the percent to a decimal. So let's do that. Forget about that line. And 100,000 times 0.6 is actually 60,000. So that's the amount he's given away. So if he's given away 60,000, the amount of candy he has left is going to be the difference. So we need to subtract the 60,000, and we get 40,000 left. So in a similar way, we can do this. Take the 40,000 times 0.6 to get 60% of 40,000, and that gives us 24,000. But that's what he's given away, so we're going to subtract that. 40 minus 24, 16,000, and we're going to continue that way. 6% of this is 9,600. We'll subtract it. That leaves 6,400. $3,840. 64. I need to get my calculator out here. 6,400 minus 3,840. 2,560. And I could continue that way. If I want to look further into this, here's a question for you. What is the common difference or common ratio? We're not subtracting the same number every time. We're subtracting the same percent. So it's going to be a common ratio. And how would I get from 100,000 to 40,000? What do I multiply by? I don't multiply by 0.6. That's the amount I'm giving away. The amount that I have here is the amount that I'm keeping. So that is actually 40% of the prior number. So R is equal to, it's basically 100% of what you have minus the 60% you're giving away. And so that is 40%. and as a decimal, R is 0.4. That's the amount you are keeping every day. So in order to calculate these going forward, I don't need to multiply by 0.6 and then subtract it. I can just multiply that number times 0.4 and continue my pattern, repeated multiplications of 0.4, and I'll have it. So 2560 times 0.4 is 1024. And if you just hit times 0.4, it'll use your prior answer, and that's what I want it to use, 409.6. Now I'm not going to give away half a piece of candy, but we'll go ahead and use these decimals just because it's what our calculator is putting out here. 163.84 times 0.4, 65.536. And so forth. This answers the questions they're asking here. So, how many pieces of candy will be left on day 4? 2,560. On day 8, basically 65 pieces of candy. Alright. So, let's model the amount of candy that would be left in the pile each day on any given day. So that's telling us we need some equations. So we have R is 0.4. That's our repeated multiplication. And let's do recursive. For recursive, remember you're going to have the first term that you need to give. Now the first term here would be 40,000, not 100,000. This would be the zero term. We'll go ahead and use the first term, 40,000, since we already have calculated it. And then f of n equals f of n minus 1, the prior term, times the r value, 0.4. That's our recursive formula. Our explicit, we need f of n equals f of 1, which is 40,000, times the r value, 0.4, to the n minus 1 power. Minus 1 because we're doing the first term, 40,000 because it's the first term. If you wanted to use the zero term, you could. So the zero term version would be f of n equals 100,000 times, the r value is the same, and now this exponent would be n minus 0, which I'm not going to write the minus 0, it would just be n. So you will see it sometimes this way. I mean, you could check a value if you want to. A lot of times I'll do that. Let's say I could plug in f of 3 and test that I get the value that I'm supposed to get at n equals 3. So I could do that right on my calculator. So I would type in 100,000 times 0.4 raised to the third power. And it should be 6,400. Whoop. It's not, because I didn't put in 100,000. Go again. That's better. 100,000 times 0.4 to the third power. That's what I'm supposed to get. Careful about entering your numbers just like that. It's when there's lots of zeros, it's easy to miscount like I just did. Alright, the next little piece. How many days will it take for the candy to be gone? Well, we could work from this. We could just continue this table. We're going to get to a point where we only have, like 1 or 2 pieces of candy left. You give away half of it, 1 piece of candy. You give away half a piece of candy. We're not going to deal with half a piece of candy. But we could think of it like this. You start up here at the beginning with that much candy, and then 40% of that would put you way down here. And then 40% of that would be way down here. 40% of that, 40% of that. So the graph would actually look something like that if you tried to graph it. I think we could just continue our table beyond 8. So let's do that. Because I don't think it's going to take that many more days. Let's see. And we'll just do this in our simple way by multiplying by 0.4. Continuing from the table above. So we have 65.536 times 0.4. That gives us 26.2144. I'm not going to write all the decimals. Times 0.4. 10.5. Day 11. We got times 0.4. 4.2. Day 12. Take that number times 0.4. 1.7 pieces of candy. And really we're at the end here. Times 0.4. Less than one piece of candy. So when do we give out a candy? I would say around day 12 or 13. You know, when we have decimals coming in here, we're not in. If we were really giving away these whole pieces of candy, we wouldn't have these decimals. So I'm not quite sure if it would turn up in day 12 or 13. Probably 13. But you could map it out without the decimals and tell. Okay. Alright, so that's it for this page. Homework tonight is listed on your Canvas page. Good luck.